Hey guys, in this section 3.4, we're going to look at the chain rule. I'm going to split this section across module 6 and 7 because module 6 is already pretty full, but I want to at least give you the basics of the chain rule and do some examples for you. So before we actually look at what the chain rule says, I want to just do an example. Suppose we want to take the derivative of this function and this function. Now, knowing what we know so far, the derivative of f of x isn't too bad, because I could take this f of x and multiply it out. Since it's 2x plus 1 squared, square the first, twice the product, square the last. And then I can take the derivative of that easily. It's going to be 8x plus 4. Now, g of x, we could do the same thing here, but raising 2x plus 1 to the fifth is going to be a pain. I mean, it's not impossible, but it's more work than I want to do and probably more work than you want to do. So it turns out there's an easy way to do this. Let's do this one first. If we do this with the chain rule, what we do is we treat the inside function kind of like it's one big variable. So we're going to get 2 times 2x plus 1 to the first power. But we're not done. What the chain rule says is when we do this, where we have a nested function, we have to multiply by the derivative of that inside function, which in this case is just derivative of 2x plus 1 is 2. So if we take this and multiply it out, we get 4 times 2x plus 1, which is 8x plus 4. Same thing we got above. And on this one, it's not that it doesn't give us a huge savings in effort, but over here it will. To get g prime of x, what we have is 5 times 2x plus 1 to the fourth times 2. So this would give us 10 times 2x plus 1 to the fourth. And that's our derivative. All right, so that's sort of the gist of it. Let's look at the actual statement of the chain rule. This says if g is differentiable at x and f is differentiable at g of x, then this composite function here, where f is the outside function and g is the inside function, it's differentiable at x, and the derivative is given by this: f prime of g of x times g prime of x. If you think about what this is, that's treating this g of x like it's a big variable, and then g prime of x is the derivative of the inside function. And it's written out here in Leibniz notation as well. But the thing that I always say to myself when I do this is times the derivative of the inside function. So let's do some relatively easy examples. All right. This one right here, we've got f of x is that thing cubed. So f prime of x is 3 times x squared plus 2x plus 1 squared, and then multiplied by the derivative of the inside function. So we got to multiply by 2x plus 2. And we're going to leave our answer like that. There's no real reason to multiply this out. And in fact, you don't really want to multiply all this out. Suppose this were a question where it asked you to find where the derivative is equal to 0. Well, what you'd want to do is set this equal to 0 and solve. And the first thing you'd have to do if it wasn't factored is factor it. So when you do this, leave your answer as you have it. Don't worry about doing too much in the way of multiplying things out. Okay, let's look at this one. Find the derivative of g of x equals 5x minus 7. All right, our inside function here is 5x minus 7, and the square root is the outside function. So I'm going to rewrite this as g of x is 5x minus 7 to the 1/2 power. And so g prime is going to be 1/2 5x minus 7 to the negative half. Then we have to multiply by the derivative of the inside function, which is 5. So I get 5 halves times 5x minus 7 to the negative half. And of course, negative half power. That means we can move this downstairs for the negative and make it a square root for the half. And that's my derivative there. All right, let's do a couple more. These two examples, notice they're similar to each other. The derivative of sine of x squared and the derivative of sine squared x. Now what's going on here is, on this one, x squared is my inside function. But this one, remember when the square is written there on the end of sine, this means it's sine of x squared. So on this one, sine is my inside function. All right, so let's do this one first up top. F of x is sine of x squared. So the derivative of sine is cosine of x squared, then times the derivative of what's inside. Now you could leave it like that, but it's more, that's totally fine. But when you have something written like this, it's like better form to write the 2x first. So you get 2x cosine x squared. All right. Down here, we'll get g prime of x. Since the squaring is the outside function, we get 2 times sine x to the first power times the derivative of sine, which is cosine x. So you get 2 sine x cosine x. And that's how I would expect you to leave your answer here. Although, you might recognize, if you know a lot of trig identities, this is actually sine 2x. I would expect you probably to leave it like this, but sometimes the book will do things like this. So, be aware. All right, I want to do just a few more here. The derivative of f of x equals e to the tan x. Okay, on this one, it might not be totally obvious what's the inside function because we don't have a set of parentheses or a radical or anything like that. But the inside function here is the tan. Tan x is inside. If you have trouble figuring out what's the inside function, look at it and figure out what you would have to do first if you were plugging in a value. Like up here, if we were plugging in a value for this thing, first thing we would do is have to do the sine of x and then square it. So sine would be the inside function. Ditto up here. If you were trying to plug in a value for x, you'd have to do 5x minus 7 and then take the square root. So 5x minus 7 is the inside function. Down here, if you were doing e to the tan x and you're plugging in some value, you'd have to take the tangent of whatever you're plugging in. Say you're plugging in 0. You'd have to take tan of 0 and then do e raised to that. So tan's our inside function. So f prime of x here is going to be derivative of e to the tan is going to be e to the tan. And then we have to multiply by the derivative tangent, which is secant squared. And let's see this last example. Is this the last one? No, it's not quite the last. Last one on this page. Find the second derivative of this. Okay, this is a lot like what we did just a second ago, except we got a cosine. But in this case, we were asked to find the second derivative. So first we have to find the first derivative. Derivative of cosine is negative sine times the derivative of what's inside, which is 2x. Now I'm going to rewrite this as minus 2x sine of x squared. And now we're going to do the second derivative, so we need the product rule here. I'm going to make this my first and this my second. So when I do f double prime, I'm going to come over here so I have plenty of space. We do first times the derivative of the second. Now, when I do the derivative of the second, I have to use the chain rule. So the derivative of this is going to be, let's see, I'll tell you what, I'm going to actually write this out in an extra step. So we get this times derivative of the second function plus second times derivative of the first function, which is going to be just -2. Actually, let me be consistent. Times derivative of -2x. All right. So now we have to do these two derivatives. This derivative is going to involve using the chain rule because it's nested. This derivative is going to be easy. It's just -2. All right. So derivative of this is going to be cosine of x squared times derivative of inside function. This is going to be sine of x squared times -2. All right, I'm going to put this together over here. On this side, we've got -2x and 2x. So this is going to be minus 4x squared cosine of x squared minus 2 sine of x squared. All right. And yeah, the last problem I want to do on this video is this one. It says that f of x is the square root of g of x. Find f prime of 5 given some values for g of 5 and g prime of 5. Okay, so g of x is my inside function. So f of x is g of x to the half. So f prime of x is 1/2 times g of x to the -half times g prime of x. And I can rewrite that as 1/2 root g of x times g prime of x. And I'm going to plug in 5 for x. So I don't need an equal here. I'm going to do f prime of 5 is equal to 1/2 root g of 5 times g prime of 5. And now I'm just going to plug in my numbers from above. Let's see, g of 5 was 16. G prime of 5 is -3. So I wind up with -3 on top and 2 times 4 on bottom. So my final answer is -3/8. All right, we've still got a good number of examples to do, but I'm going to save those for the next video. And those are going to be ones where we have to do some significant mixing of product rule, chain rule, and quotient rule. So we'll pick up there in Module 7.